Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Constraint Steps by E. Biggie. And here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 in each row, column, and box. Crop key. White dots are consecutive. All dots are given. So this is a negative constraint where basically you cannot have consecutive digits in any two adjacent cells unless there is a white dot in between them. So, for example, if this were let's say this is a 6. If this is a 6, this would have to be a 5 or a 7. But if this were a 6, 5 and 7 could not be in the cells that are orthogonally adjacent to it, which is basically sharing an edge. So remember that negative constraint. This could not be 5 or 7 if this were a 6. We also have German whisper lines, where adjacent digits on a green German whisper line must differ by at least 5. Digits may repeat if other rules allow. So for example, if this was a 3, this would have to be an 8 or a 9, because the only digits that are 5 or more away from a 3 are an 8 or a 9. So that's why that would have to be the case. We also have a Renban line here, where digits on a purple Renban line must be a set of consecutive, non-repeating digits and may appear in any order. So, for example, this could be something along the lines of 6, 3, 7, 8, 5, 4, right? Because they're consecutive, they are not repeating, and that's the only requirements, right, for a Renban line. And then finally, we have region sum lines, which are blue. Digits on a blue region sum line have an equal sum n within each box it passes through. Region sum lines must cross box borders. So, for example, these 4 digits, well, this is the only example, these 4 digits must equal the same as what these 3 digits must equal. So as an example, it could be something along the lines of 7, 8, and 9, and then this could be 9, 3, I don't know. No, it can't be 6. 3, 8. Does this work? And 4. Yeah. So this is a valid example of a region sum line because these add up to 24 and these add up to 24. And those are all the rules, and this is specifically for our colorblind people. The region sum line is this line. The Renban line is this line. And all the other lines are German whisper lines. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So whatever this digit is, it cannot be on the Renban because you can't have repeats. It can't be that digit. It must be one of these 3 digits, but we're not sure which. So this digit is one of these 3 digits. So it must be one of these 3 digits too. Therefore, this cannot be a 5 because 5 cannot be on a German whisper line. So 5 has to be one of these cells here. Because of that, we know these 2 cells at least have to be the same entropic value, which means, but specifically it has to be low or high, right? And on German whisper lines, we know that we can divide lines into low and high sets, and they'll alternate between them. So first, let's make sure this is a 5. And let's start alternating between for the German whisper line. So this could be low or light. We're going to put light and dark, I guess. This is light and dark. This is light. This is dark, light, dark, light. Well, these are consecutive, and they're both on a German whisper line. So they have to be the same low or high value, right? Because you can't cross 5. So this is low, light. This is dark. This is light. This is dark. This is light. And this is dark. This is also on... Okay, light and darks. I'm going to change... Well, this is fine. These are also on German whisper lines and are consecutive. So, and it cannot be 5, obviously, so it has to be the same set. So this is dark, this is light, this is dark. But it could be consecutive with a 5. This both have to be light. Oops. They have to be light here because it's not a 5. And again, it's consecutive with it. One of these is light, one of these is dark. Okay, this is also dark because it's consecutive with another digit that's on the German whisper line, so it can't be 5. Therefore, this is light, this is dark, light, dark, and this is light. This has to be light, and this is dark. We don't know if this is... These two are the same set, so we're going to mark them both orange. Therefore, we're going to make these yellow. So this is yellow, this is yellow, this is orange, and this is yellow. This must be yellow, which makes this orange. Well, again, these two, the cells, are consecutive, and they're both on a German whisper line, so they must be the same set. So this is orange, which means we have, if the orange were the same set as the darks, there would be 5 oranges in column 6, which is not allowed. So we're going to mark the darks now as orange, or not as orange, they're yellow. So the darks are yellow, and the lights have to be orange. This must be yellow, which makes this orange. Okay. What do we have? We have, okay, so in column 5, we have 4 oranges now, which means the rest of the column must be yellow or pink. Okay. What else do we have? We know these cannot be 2 oranges, because if they're 2 oranges, there would be 5 oranges here. One of them could be an orange, though. This has to... Whoops. This has to be yellow or pink, because it's consecutive with a yellow. This has to be orange or pink because it's consecutive with an orange. This has to be yellow or pink because it's consecutive with a yellow. These are orange or pink because they're consecutive with an orange. Um, hmm. We have 4 yellows in box 5, which eliminates yellow from the rest of the box. Um, that means the rest of the box is orange or pink. Okay. Hmm. Okay. In box 6, we know one of the cells in column 4 is orange, and one and only one cell is orange. Therefore, in the rest of column 4, one of these cells has to be pink, because if all of them were orange, we'd have 5 oranges. So there cannot be a pink in column 4 in box 8. Where is the pink? It has to be here. So this is pink, which means this cannot be pink. This is yellow. One of these 3 is a pink here, but we're not sure which. Um, hmm. That means this is pink. So this is a 5, which means none of these can be 5. So one of these is a pink, and we're not sure which one the other one is. So here we have 2 yellows and 2 pinks here. That means 2 yellows and 2 pinks have to also be on this red band line, which means we require a 4 on this red band line has to be 3 through 7. And it's either with a 2 or an 8 at the end. So this has to be 3 through 7 here, with a 2 or 8 at the end. So it could be 2 or 8 here. These obviously can't be 5. This is 2, 3, 4, 6, 7, 8. Whichever one is here has to be one of those 3 cells. But we don't know which one it is. Okay. Where? Okay, what else do we have? Oh, all dots are given. Interesting. Okay, so where is the 6 in column, or where is the orange 4 or 6 in column? Oh, wait, that's another thing that's interesting. In box 5, Well, that's not helpful. Hmm. None of these are consecutive either, though. That's interesting. So we don't know what this is. Pink could be either of these, but we do know this has to be orange or pink to be consecutive with this. Because 5 has to be one of these. This can't be 5. This cannot be two yellows here. But we don't know if it could be a yellow or pink. Or it could be an orange. Or orange and pink. Or two oranges. We just don't know. This is yellow or pink, but we don't know what it is. This is 5, so this cannot be 4 or 6 here. Interesting. This can't be 4 or 6. And this can't be 4 or 6, but that's obvious there. Uh... Oh. This can't be 5, so one of these 4 is 5. What else do we have? Where are 1 and 9 in box 7? 1 and 9 cannot be here. They can't be on the Ren band. So 1 and 9 both have to be here. And if this is 1 or 9, this has to be specifically 1 or 9. Right? Because the yellows are the opposite set. So if one of these is 1, then the other one has to be 9 here. So this has to be 2 or 8, which means this has to be an orange. It cannot be pink. So this has to be 3 or 7 here. Which means it cannot be pink. It's an orange and is therefore 3 or 7. This then has to be the 5. This can't be pink. This could be pink. We have 4 oranges in column 3, which eliminates orange from the rest of the column. So this could be yellow or pink. This has to be yellow because it can't be pink. This is pink, so one of these two is pink. Where is the pink in? Therefore, where is the pink in the rest of column 3? Has to be one of these two. Therefore, these cannot be pink. So the pink in column 2 has to be one of those two cells. Okay. This is yellow, yellow, yellow. We have one more yellow. This cannot be... Well, it could be 1 or 9. No, cannot be 1 or 9. So it has to be one of the yellows. So this is yellow here, which means we have one red and one yellow here. This is one red and, or sorry, one yellow, orange and one yellow. This is one orange, one yellow. This is one orange and one yellow. We're not sure which one's which. Let's see. This cannot, could be orange. Hmm. These cannot be consecutive. So if this were 4 and 6, those would have to have a consecutiveness. So one of these is 4, 6. So it's 4, 6 with 1, 2, 8, and 9. This is just 1, 2, 8, or 9 here. Hmm. No. What else do we have? So the orange 4, 6 cannot be here. So this is 1, 2, 3, 7, 8, 9. Interesting. Either this is 4 or 6, or this is 4 or 6, right? Because if the 4, 6 is here, this would have to be the corresponding 1, 2, 8, 9, and they would have to be consecutive. So, since one of these is 4 or 6, one of these has to be 1 or 9, but we don't know which one. Huh. So this actually, okay, so this can never be pink. If this is pink, it's consecutive with, it would only be consecutive with 4, 6, but this digit is next to two unique digits on a German whisper line. Therefore, it cannot be pink. It has to be yellow, which means this is the 5 and is pink. So this is pink, which means this cannot be pink. This is another orange. This has to be 4 or 6 here. But it's not the orange one. It has to be the yellow 4 or 6. So this is yellow. We have 4 yellows now in row 3. And therefore the last one must be orange. So this is the yellow 4, 6. We have 4 yellows here. So this cannot be yellow. This has to be orange. This is some combination of 2, 8, 3, 7, but this cannot be 1 or 9 here. This has to, okay, this is in between two unique digits on a German whisper line, so it cannot be 4 or 6. It has to be the 1, 9 here. Which means this cannot be 1 or 9. So this cannot be the yellow 4 or 6. Because it's not next to a 1 or the orange 1 or 9 here. Same, this is next to two unique digits on German whisper line, so this has to be 1, 9, 2, 8, or 3, 7 here. These cannot be the orange 1, 9. It's 2, 3, 4, 6, 7, 8. But this is consecutive. Could be. We don't know about that one. This is next to two unique digits, so this is 1, 2, 3, 7, 8, 9. This cannot be 4 or 6. If this were 4 or 6, it would have to be next to a 3 or 7, but it's not. So therefore, this is also 1, 2, 3, 7, 8, 9, and this is also 1, 2, 3, 7, 8, 9. So this cannot be 4 or 6. This is next to two unique digits, so that's why it's 1, 2, 3, 7, 8, 9. This is next to two unique digits on a German whisper line, so it's 1, 2, 3, 7, 8, 9. This, again, if we try to make this consecutive, you can never have 4 and 6 here because it means to be next to 3 or 7. This cannot be 4 or 6 next to a 3 or 7, and all the other oranges are taken by this 1, 2, 3, or 7, 8, 9 triplet here. So this has to be pink and is a 5, which makes this the 4 or 6, which makes this the 1 or 9 here. So this can't be 1 or 9. This cannot be 4 or 6 then. This is 1, 2, 8, 9. This is 4 or 6. Where is the orange 4 or 6? Cannot be here. It has to be here. So this is the orange 4 or 6. This has to be yellow. This can't be pink anymore, so it's also yellow. This can't be 4 or 6. This can't be pink. So this is orange, which means this can't be orange. This is the pink, so this is 5. This has to be 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. Let's see. This cannot be 1, 9 yellow. So this has to be the 1, 9 yellow, which means this is the same as this digit. So it's 2, 3, 4, 6, 7, 8. But we don't, yeah, so these are both, we'll mark him as A. 1, 9 has to be with the 2, 8 yellow. So this sees both the 2, 8 yellow and the orange 2, 8. So this cannot be 2, 8 in either way. This cannot be 4, 6 orange. It has to be, it could be 1, 2, 3, 7, 8, 9, though. This cannot be 2, 8, or 3, 7 yellow. And we can't have a 4, 6 here because that's between two unique digits on a German whisper line. So this must be 1 or 9. This is next to two unique digits on a German whisper line. So it's 1, 2, 3, 7, 8, 9. This is 2, 3, 4, 6, 7, 8 here. This cannot be 2 or 8 or 1 or 9. So it could be 3, 7, or it's 4, 6, or it's 5. I'm not sure. One of these is 2 or 8. So this cannot, this is 3, 4, 5, 6, 7 also. Okay. So one of these, okay, so this cannot be the orange 4-6 because it's between two unique digits on a German whisper line. So this is the orange 4-6 here. This cannot be 2 and 8 because we have all the 2 and 8s in the column. So this has to be 3, 4, 6, 7. And this is also 3, 4, 6, 7. This is 3, 4, 6, 7. So the orange 4-6 has to be one of these two. So this cannot be orange 4-6. It cannot be orange 1-9. So this is orange 2-3-7-8. This A has to be one of these two cells. We're not sure which. This is 1-2-3-7-8-9 as possibilities. This is 1-2-3-7-8-9. But this could be any of them. This cannot be yellow 2-8. But it could be any of them so far. This cannot be yellow 1-9. It's either yellow 2-8 or yellow 3-7. This one could be yellow. It cannot be yellow 4-6. Where is the yellow 4-6 in box 2? It has to be here. Which means this has to have the yellow 2-8 here to be consecutive. So this cannot be 2-8 here. One of these has to be the yellow 2 or 8 because we can't have yellow 4-6. So it's either yellow 1 with 2 or 2 with 3 or yellow 7 with 8 or yellow 8 with 9. So this has to have the yellow 2 or 8 here. And this also has to have the yellow 2 or 8 here. This is between two unique digits. So this is 1, 2, 3, 7, 8, 9. I guess we can just do it that way. One of these digits is the yellow 4-6 because it cannot be here and there's no other yellows in this box. Therefore, this cannot be yellow 4-6. Therefore, this must be the yellow 4-6. So therefore, this is the orange 1-9, which makes this the orange 2-8, which means this can't be the orange 2-8. This can't be the orange 2-9 or 1-9. So this is the orange 3-7, which makes this the orange 4-6. So this is orange 4-6, which is next to the yellow 1-9, which means this can't be yellow 1-9. So this is the yellow 3-7, which can only be next to the orange 2-8 here. So the orange 2-8 is here, here, and here. This is yellow 3-7, so this can't be yellow 3-7. This can't be yellow 3-7. So the yellow 3-7 in box 7 has to be one of these cells too, which means this can't be the yellow 3-7. It's the yellow 2-8 or 4-6. We're not sure which. This is the yellow 3-7, so this can't be yellow 3-7. That's a 1-2-8-9 yellow. One of these is the yellow 3, 7 here. We also have the orange 1, 9 here, so this cannot be 1, 9 or 1, 9. So this has to be the orange 1, 9 here. This has to be the orange 4, 6. This can't be 1, 9, 1, 9, so this is 2, 3, 7, 8. Hmm. This can't be the orange 2, 8 here. This can't be the yellow 2, 9, or 1, 9. So this has to be yellow 2, 3, 7, or 8. This can't be, we have both yellow 2, 3, 7, 8s in box 2, so this can't be the yellow 2, 3, 7, 8, so it's the yellow 1, 9, which must be next to the yellow 2, 8. So this can't be yellow 2, 8. This is yellow 1, 3, 7, 9. This can't be the yellow 1, 9 because of that yellow 1, 9, so this is the yellow 3, 7, which means this can't be yellow 3, 7. This is the yellow 1, 9. Yellow 3, 7 cannot be next to orange 3, 7 because 3 and 7 can never be next to each other on a German whisper line. So this is the orange 2, 8, which makes this the yellow 3, 7. This cannot be 3 and 7 then because the yellow, it's either yellow 3, 7 or one of those. This can't be the yellow 4, 6 because of that. It cannot be 4, 6 here either. So this is a 3, 7, which means it cannot be the yellow 3, 7. It has to be the orange 3, 7. Well, we have a 3, 7 pair, essentially. One of these is 3 or 7, and this is 3 or 7. So the rest of the column cannot contain 3 or 7. So this is not 3 or 7. This can't be 3 or 7. So this is 4, 6. This is 4 or 6. We don't know which one is which, though. Oh. No, we don't know anything about that. This is 4, 6. This cannot be orange 3, 7. So we have both orange 1, 2, 8, 9s. This is 3, 4, 5, 3, 4, 6, 7. We're not sure which is which, though. Cannot be orange either way. Sorry, cannot be yellow either way because we have the 3, 7 yellow and the 4, 6 yellow seeing that. So this has to be orange. Since this is orange, we have 4 oranges now. Therefore, this must be yellow. Which means this cannot be yellow 4, 6. So it has to be 5. Which means this is the yellow 3, 7. Which is next to either one of these. This can't be the yellow 3, 7. Therefore, where is the yellow 3, 7 in box 7? It has to be here. This can't be yellow 4, 6, so this is orange 4, 6. We have a yellow 2, 4, 6, and 8. This has to be A, then. Because we have both yellow 2, 4, 6, and 8 accounted for in row 9. So this can't be A. This has to match A. We have remaining an orange 1, 9, which has to be here. We have a yellow 1, 9, which has to be here. Therefore, this must be specifically 2, 8, or 3, 7 for yellow. This can't be the yellow 3, 7. It has to be the orange 3, 7. It has to be the orange 4, 6. Hmm. We have the orange 1, 2, 3, 7, 8, 9, but it cannot be 1, 9 because of that 1, 9. This is either orange 1, 9 or orange 3, 7. We already have 4 yellows here, so this is, sorry, 4 oranges, so this is yellow, and it has to be 2, 4, 6, or 8. Well, the remaining 2 digits here are orange. So one of these is an orange 3, 7, but we're not sure where that is. This cannot be the orange 2, 8, so therefore one of these is orange 2, 8. One of these has to be orange 4, 6, and the other is the yellow 2, 4, 6, or 8. We have remaining here a yellow 4, 6 and an orange 1, 9 and 3, 7. One of these is 5. One of these is 5. We need a yellow 2, 8. An orange 4, 6. Well, yellow 2, 8 cannot be here. And a yellow 3, 7. Okay. Yellow 2, 8 and 3, 7 cannot be here. So this is yellow. This is yellow. This has to be orange then, which is orange 4, 6. This is 2, 3, 7, 8. This is 2, 3, 7, 8. Orange 4, 6 cannot be here. Cannot be here. It must be here. So this is orange 4, 6 now. We have all the oranges in column 7. So the rest of them must be yellow or pink. This can't be pink. This has to be yellow. We now have all the yellows in row 2, which eliminates yellows in the rest of the row. So this must be orange. This has to be specifically be a yellow 1, 9. This is an orange 2, 3, 7, or 8. Um, hmm. We are looking for a yellow 1, 9. But this cannot be a yellow 1, 9 because of that yellow 1, 9. So this must be pink. Which means this can't be pink. This can't be yellow 1, 9 because of that yellow 1, 9. Therefore, this is the yellow 1, 9. This is pink, which makes that a 5. This has to be the orange 2, 8. Okay. The remaining digit here is a yellow 2, 4, 6, 8. Oh, okay. Well, we have 2 yellow 2, 4, 6, 8s here, which eliminates the yellow 2, 4, 6, and 8 in the rest of the column. So this can't be 2 or 8. This is 3, 7, which means this can't be 3 or 7. So this is the yellow 2, 8. This can't be the yellow 2, 4, 6, or 8. So this must be the yellow 3, 7, which makes this the yellow 4, 6. The yellow 4, 6 cannot be here. Cannot be here. It must be here then in column 8. So this is the yellow 4, 6, which makes this the orange 1, 3, 7, 9. here we're looking for the orange 1 through 7, 1, 2, 3, 7, 8, 9, and then 5. So it's 5, 1, 2, 3, 7, 8, 9. We're not sure which is which. Okay, so these are the same. If orange were low, 3. If orange were low, this would be 3, and this could not be. This would have to be 2 highs, which is impossible. So the oranges are the highs. So the oranges are high, which means all the 1 9s, reds, the yellows are the lows. So all the blue lows are a 1 for 1 9. So these are all 1. Okay. All the high 1 9s, but there's a lot of variance here, are 9s. So these we don't know information-wise. So these have to be all 9s. For the low 2 8s, obviously they're 2. You know, I'm just gonna number them. So this is 2, this is 2, 3, 3. This is 3, 2, 3, 4, 4, 3, 4, 3. So this is not 6 or 8. These are not 6 or 8. This has to be 8 here. This is 7, this is 6. This is not 6 or 8. This is not 6 or 8. This is a 6. This is a 6. This is a 4. Not 7 or 8, not 7 or 8. These are at 7 or 8. This has to be a 4. This is a 6, 8, 6, 7. No 1, 2. No 1 or 2. So it's 8 or 9. So this is 5 and 6. This is a 6. This is not 1, 2, or 3. This is not 7 or 8. No 7 or 8. This can't be 2 or 3. It can't be 1 or 2. It can't be 2 or 3. No 2 or 3. This has to be a 7, and this is an 8. This is a 4, and this is a 6. This can't be 1, 2, or 3. This can't be 2 or 3. This can't be 1 or 3. No 1, 3. This is a 6. This is an 8. This is a 7. This is 6. This is 8. This cannot be 1 or 3. This is 5 or 7 here. This can't be 8 or 9, so this is 5 or 7. 7 or 9, 7 or 9. This 6 is the same. What happens if this is a 7? If this is 7, this is 9, this is 7. So if this is 7, this is 9, this is 7. This 7 would force this to be 2. This would have to be 3. So this would be 5, 6, 7, which adds up to 18. This would be 3, 4, and 6, and a minimum of 5, which adds up to 18. So that works, actually. Except, does it? Hmm. If this is 3, that makes this a 2. That makes this 3. So if this is 3, that would make this 2, which makes that 3, which makes that 9, which makes that 7, which makes that 9. So can this add up? This would be 9 here, this is 9 here, this is 6, and this would be 5. If this is 3 and this is 2, oh, I already tried that. If this is 2 and this is 3, this is 2. Can this, what, this adds up to 13. This adds up to 11. So that actually works with either, I think. So this is 7, that could be 9. Huh. Right. So that does work, I think. Well, but hold up. So if this is... Hmm. Okay, how does... Okay. What are the scenarios here? So specifically this and this set. And this. Everything else can be anything, essentially. Unfortunately. Hmm. These are B. Oops. B, B, and B. Seven's one of these two. That's fine. So again, if this is 2, this is 3, that forces this to be 2. This is 3. Okay, so that's not... Let's go this way. If this is 3, this is 2, this is 3. This becomes 2, which makes that a 3, which makes that 8. So this is 7. This is 9. This is 8. So that's fine. This is 7. This is 9. This is 7 and 9. This 9... Oh. How did I... Okay, so that's part of the problem. I added wrong. This 6 and this 6 is fine. This adds up to 14, so this is 20. This adds up to 12, which needs an 8 to add up to 20, so that doesn't work. So this cannot be 3. This has to be 2, which makes this 3. That makes this 2. This 2 means this has to be 3, which makes that a 2. This is already 13. This is 11. So this has to be 2 greater than this. So if this is 7, this is 5. If this is 9, this is 7. Either way, both of these see 7, so this can't be 7. This must be an 8, which makes this 7. This can't be 7 here. This can't be 8 here. This can't be 7 here. Hmm. Uh, hmm. Um, huh. It still looks like it could be either. Huh. Let's try them out, I guess. If this is 5, that means this is 9, this is 7, this is 9, this is 7. So this is 18. This is also 18. So that works. That would be then 8, 7, 8, 9. That seems fine. If this is 7, that makes this 9, which makes that 7. Therefore, that's 8. This is 7, this is 8, this is 9, this is 8, this is 9. This is 9. So this is 10, 20, this is 20. We also have a problem here, right? I don't know how we disambiguate these. Oh, consecutiveness. I forgot about that. Okay. This can't be 2. There you go. Because it's next to a 1. So the A's are all 4s. And the B's are all 2s. So these are 2. This cannot be 7 because it's consecutive with an 8. So this must be a 5. This can't be red. This can't be pink. This can't be pink. This can't be red. So this is 5, which makes that 7. That makes that 9, which makes that 7, which makes that 9. This has to be 7. This is 5. This can't be 7, so this is 8, which makes that 7, which makes that 8, which makes that 9. That makes that 8 by normal Sudoku. This has to be a 3, and this is a 9. And that's how you solve it. Wow, great job. Those negative constraints didn't slow you down a bit. Well, they did, actually. They did actually slow me down a little bit because I forgot about it. Yeah, and that's how you solve that puzzle. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.